Every night, the universe glows with a light so old it remembers a time before stars, before galaxies, before even the first breath of cosmic clarity. It is a faint shimmer, softer than moonlight, spread across every direction you could point your gaze. This glow has travelled for nearly 14 billion years, drifting through expanding space, cooling as the cosmos stretched. And tonight, in the quiet of your room, we will follow this ancient radiance back to its beginning, the universe's oldest light. Welcome to AstraFlow. Here, science drifts like starlight, and curiosity becomes calm. Tonight, let your thoughts slow down, your breathing find its rhythm, and your mind float through wonder. Before we begin, I'd love to know where you're listening from. Are you lying in bed under city lights, or watching the stars from somewhere quiet? Tell me in the comments. It's always peaceful to imagine the AstraFlow community scattered across the world, drifting together through the same sky. And if this calm journey brings you peace, you can gently support AstraFlow by liking this video or subscribing. It helps this little corner of the cosmos keep glowing. Now, let's begin tonight's voyage into the quiet story of the mystery of cosmic background radiation, the universe's oldest and softest whisper of light. When astronomers speak of relics, they often think of stones, fossils, or ancient artifacts dug out of forgotten ground. But the universe itself holds an artifact older than any world could bear, a cool, dim radiation that fills all of space. It is everywhere around you, even now, passing through walls, drifting through the night air, brushing against your skin as silently as a thought. This is cosmic background radiation, a remnant from the birth of everything, preserved through time like a memory the universe was too gentle to let fade. As you breathe slowly, imagine this faint glow surrounding you, the echo of an event so distant it blurs the line between beginning and eternity. Imagine that each photon, each tiny flash of light, has travelled unbroken since the cosmos was young and bright, and filled with a swirling fire that no eye today could endure. These are the storytellers of creation, still wandering, still whispering, still carrying the imprint of what the universe once was, and tonight we follow them. Not with urgency, but with ease, drifting backward through time, letting their soft hum guide us into deeper calm. Their story begins long before the first star flickered awake, and by tracing their path we walk gently toward the earliest chapter of existence itself. What does it mean for light to remember? It's a quiet question, almost poetic, yet at the heart of one of the greatest mysteries in cosmology. When we look into the night sky, we're used to seeing stars as snapshots of the past, their shine delayed by distance. But cosmic background radiation is different. It doesn't show us a moment from a star's life. It shows us the universe itself before the concept of stars even existed. So we begin with a question older than galaxies, older than time as we understand it. Why does the cosmos keep an imprint of its own birth? And what does it mean for us to stand here, billions of years later, tracing that whisper back to its beginning? As your breath falls into a slow rhythm, imagine the universe as an infant, barely formed, wrapped in a glowing cocoon of heat and energy. There were no constellations, no planets, no quiet nights. Only a sea of particles and radiation, too dense and too bright to let anything take shape. In that early fire, the universe held no memories, only motion, only heat, only the raw unfolding of existence. Yet somewhere within that chaos, the seeds of remembrance were planted. When the universe finally cooled enough to let light travel freely, something remarkable happened. The glow that filled everything didn't fade away. It simply began drifting outward, aging without dimming, stretching with the expansion of space. Pause for a moment and picture that. Photons born in a world of blinding brightness, still travelling now, soft and cool. Passing silently through your room as you lie here, they have crossed everything, voids between galaxies, clusters of unimaginable scale, horizons of darkness, yet their journey has never stopped. They're carrying not just energy, but information. They contain the tiny variations, the subtle ripples, the first imprints of structure that would one day grow into stars, planets, oceans, and the living beings who now wonder about them. So our question deepens. What does it mean that the universe remembers its beginning so clearly? Perhaps it suggests that creation is not a moment, but a long unfolding, that the cosmos doesn't simply emerge and forget, it expands and preserves, layering time into light. Or perhaps it reminds us that even the smallest imprints can shape everything that follows. A gentle ripple in the earliest plasma becomes a galaxy. A tiny fluctuation becomes a home. A faint photon becomes a message carried across eternity. Tonight, as we drift through this ancient glow, we follow these questions not to solve them, but to rest inside them, to let their softness ease the mind and slow the world around us. When you look up at the night, your eyes meet the familiar constellations, quiet shapes traced across darkness. Yet behind that darkness lies something deeper, a second sky layered beneath the first. It is not visible to ordinary vision, and it does not flicker like stars. Instead, it glows with a soft, uniform warmth, the faintest whisper of the universe's earliest moments. This hidden backdrop is the cosmic microwave background, the sky behind the sky, an ocean of ancient light spread evenly across every horizon. Imagine peeling away the glitter of the Milky Way, removing stars one by one until only emptiness remains. Even then, with nothing left to illuminate the void, something still glows, a gentle wash of microwave light, so cool and so subtle that it passes through everything without noticing. It has no shadows, no direction, no beginning or end in the sky. No matter where you look or how far you travel, the same faint glow surrounds you. The universe is wrapped in it like a quiet, ever-present blanket. This light is not created by stars or galaxies. It is not the product of nuclear fires or cosmic collisions. It is older than all of them, a relic from a time when the universe was small, dense and filled with a blinding brightness. Back then, photons could not roam freely. They bounced endlessly through the thick plasma, scattering like echoes in a crowded hall. But when the cosmos cooled enough for atoms to form, the fog thinned, and those trapped photons escaped at last. They rushed outward in every direction, their release marking the first moment the universe became truly transparent. The glow we see today is the cooled remnant of that release. Over billions of years, the expansion of space stretched its wavelengths, softening its once fiery brilliance into a gentle microwave hum. What was once light too bright to behold has become a calm, uniform warmth, a kind of cosmic afterglow. As you rest, imagine this background as a soft wall of memory behind everything you can see. Every galaxy, every star, every drifting cloud of dust floats in front of this ancient radiance. The dark spaces between constellations aren't truly empty. They're filled with this oldest light, smooth and steady like a long, slow exhale from the universe itself. To observe the cosmic background radiation is to see not just the night sky, but the foundation beneath it, the quiet imprint of what the universe once was, a hidden world beneath the stars, waiting gently for us to notice. To understand cosmic background radiation, imagine the universe not as the vast, cool expanse we see today, but as a newborn world, hot, dense, glowing, with an intensity beyond anything the human eye could bear. In those first hundreds of thousands of years, the cosmos was filled with radiant heat, a brilliant fog of particles and photons swirling together in a restless dance. Light existed, but it could not travel. It was trapped, scattered repeatedly by charged particles, unable to take a straight path or carry a story of its own. Think of watching sunlight through thick clouds, where brightness fills the air but nothing has shape. That early universe was like that, only far hotter, far denser, and far more chaotic. Every direction was glowing, every particle was jostling. And through that sea of motion, light waited, impatient, yet unable to break free. This is where cosmic background radiation begins. In a world young enough that time itself felt thick, where the universe had not yet calmed enough to let clarity form. As the cosmos expanded, it also cooled, slowly losing the intense heat that kept particles from settling. Gradually the fog of charged matter began to thin. Electrons found protons, atoms formed. And in that moment, so small compared to the age of everything that followed, light finally became free. That release was quiet yet transformative. Photons that had been confined for ages suddenly leapt forward, spilling into open space. They travelled outward, filling the entire universe in every direction. This was the first time the cosmos allowed light to move unimpeded, and that transition marked a turning point. The universe was no longer opaque, it was transparent. The glow from that ancient moment still exists today. It has cooled from a fierce white blaze to a soft microwave warmth, stretched like a gentle wave through expanding space. Yet despite all that change, it still carries the imprint of the universe's youth. The temperature variations, the tiny fluctuations in density, the delicate ripples of early energy, all of it remains recorded in that glow. As you lie here, breathing slowly, imagine those photons drifting around you. They were born when the universe was only a few 100,000 years old. They have travelled for nearly 14 billion years without stopping, and even now they continue onward, moving through you as part of their endless journey. This faint radiation is the oldest light we can see, a quiet echo from a time when everything was young. To follow it is to watch the universe take its first clear breath. Imagine standing inside a dense morning fog, the kind that softens sound, blurs shape, and turns even familiar landscapes into drifting silhouettes. Now imagine a fog not of water droplets, but of particles and radiant heat, filling the entire universe. For hundreds of thousands of years after the Big Bang, this was the state of everything. A thick, glowing plasma where light could not travel more than a tiny step before being scattered again. The cosmos was bright, yet no point of view existed. Nothing could be seen, nothing could cast a shadow. It was a world without clarity. As you breathe gently, picture that early fog drifting slowly, slowly thinning. Not through wind, not through motion, but through cooling. When the universe was young, its temperature was unimaginably high, hot enough that atoms could not hold together. Electrons and protons floated freely, forming a soup of charged particles that trapped every photon in a constant cycle of collisions. In that environment, light was restless, jittery, never able to escape into open space. But the universe was expanding. An expansion brings cooling, like a long, slow exhale stretched across time. As temperatures dropped, the fog began to settle. Particles that once resisted bonding found themselves drifting into balance, and gradually the opacity of the cosmos started to fade. The universe, once too bright to see through, started learning how to become transparent. This process wasn't sudden. It unfolded gently over thousands of years, like dawn emerging through layers of mist. As atoms formed, the fog lost its grip on the light. Photons, once trapped in an endless scattering dance, began to move more freely. The cosmic haze thinned until finally, one quiet moment arrived. The moment when the universe let go and allowed light to flow without obstruction. That moment is what we call recombination, but the name hardly captures how delicate the transition was. It was as if the cosmos itself was taking its first clear breath. For the first time, light had room to wander. It no longer bounced, it travelled. It no longer rattled in place, it flowed across space. The fog did not disappear entirely, it simply transformed. The universe became a vast, open expanse, cooling into darkness. But the photons that escaped during this transition continued onward, carrying with them a snapshot of that fading fog, its temperatures, its density, its ripples of early matter. As you rest, imagine the fog lifting around you, revealing a world that has always been present but only now visible. That is what the universe experienced. A slow unveiling, a gentle clearing, a shift from glowing haze to open sky. There's a moment in every dawn when the world seems to hold still, a soft pause between shadow and light, when the air feels suspended, waiting. The early universe had such a moment too. After hundreds of thousands of years wrapped in a glowing fog, everything reached a delicate threshold. Temperatures cooled just enough, motion eased just enough, particles slowed just enough. And in that fragile balance, the cosmos took its first true breath of clarity. This moment is known as recombination, though the name sounds more mechanical than the event itself felt. It was a quiet shift in the very nature of the universe. Before this moment, electrons and protons drifted separately, unable to combine. But as the universe cooled, these tiny particles finally joined, forming the first stable atoms, mostly hydrogen, with a touch of helium. In that simple union, the entire cosmos changed its state of being. As electrons settled into place, the fog that once trapped every photon began to collapse. Light, which had been bouncing endlessly in every direction, suddenly found no obstacles in its path. It no longer rattled in confinement. It was released. Imagine millions upon millions of doors opening at once, and the light rushing outward in every direction, eager for the open space that had never before existed. Those photons became travellers, and they never stopped travelling. Even now, as you rest, that same ancient light is passing through you, billions of years old, yet untouched by anything but the gentle expansion of space. It carries no sense of hurry, no urgency, only momentum. It has drifted across cosmic emptiness with the steady calm of something that has all the time in the universe. The first breath of clarity also marked the beginning of darkness. Once the light escaped, nothing remained to illuminate the cosmos. The universe dimmed for the first time, slipping into a long night that would last until the first stars ignited. Yet in that darkness, opportunity bloomed. With the fog gone, gravity could work quietly, gathering matter into clumps that would one day become galaxies, suns, planets, and everything we have ever known. In a way, recombination is a moment of stillness that lives inside every star we see today. Without that release of light, without that first clearing of the cosmic haze, the universe would never have unfolded into structure. It would never have settled into a form where beauty could take shape. As you breathe slowly, imagine that ancient stillness filling you, a universe exhaling its fog, becoming clear for the first time. In that clarity, the oldest light began its journey, a journey we're only now learning to read. If you could turn off every star in the sky, every burning sun, every glowing nebula, every distant galaxy, space would not become truly dark. Not fully. Even with all familiar lights extinguished, a soft radiance would remain, spread gently across every direction. It is not bright. It does not shimmer. It has no beginning or boundary in the sky, but it is everywhere. Cosmic background radiation fills the universe like a calm, even breath stretched across infinity. As you rest, imagine holding out your hand into the air around you. invisible waves pass through it. Quiet microwaves, cool and steady, each one a whisper from the universe's youth. They do not warm you, and you cannot feel them, yet they envelop every corner of existence. No matter where you look, no matter where you travel, this glow remains the same. It does not fade at the edges, it does not collect in pockets. It is evenly woven through the fabric of space, a quiet reminder that all of us live inside the memory of a single ancient moment. This uniformity is one of its most calming qualities. Stars may flare and die, galaxies may collide or drift apart, space may stretch and thin with time, but the cosmic background remains steady, like the hum of an engine far too large to hear directly. It is the universe's baseline, its softest note, its ever-present backdrop. What makes this glow so special is not its brightness, but its persistence. Photons from the earliest era have travelled so far for so long that they now form a vast spherical shell of light surrounding every observer. Wherever you stand in the universe, you sit at the centre of your own cosmic horizon, wrapped in the same cool radiance. This is why astronomers say the universe has no centre. Every point experiences the glow as if it were the middle of everything. The cosmic background's brightness is tiny, barely above absolute darkness, but its presence is absolute. Telescopes see it not as a beam or flare, but as a soft wash of warmth. 2.7 degrees above absolute zero. That faint temperature is the universe's heartbeat, still pumping gently across cosmic time. As you breathe slowly, imagine that glow expanding with your inhale, softening with your exhale. It is a light that has never gone out, a memory so evenly spread that it touches every horizon we can name. It does not demand attention, it simply exists. Quiet, patient, persistent. A glow that fills every horizon, holding the story of everything that followed. If you could take the temperature of the universe, not of a star or a planet, but of space itself, you would find something astonishing. The cosmos, once unimaginably hot, now rests at a gentle chill, 2.7 Kelvin, just a few degrees above absolute zero. This is the temperature of the cosmic microwave background, the faint glow that fills every direction. It is the thermal after-image of creation, cooled by billions of years of cosmic expansion. As you settle deeper into stillness, imagine this ancient warmth spread thinly across the universe, stretched like a delicate blanket over everything that exists. It isn't warm to the touch. You wouldn't feel it brushing your skin, yet it is there, surrounding you, passing through you, humming softly through empty space. A gentle remnant of a time when the universe was bright enough to outshine every star that has ever lived. The universe didn't cool because it lost heat into some surrounding emptiness. There is no outside. Instead, the cooling happened because space itself expanded. As the cosmos stretched, the wavelengths of ancient photons stretched with it, turning hot, dense radiation into long, low-energy microwaves. What once glowed with a fierce white brilliance now flows with a calm, steady coolness. The universe grew, and in growing, it softened. This 2.7 Kelvin temperature is one of the quietest clues we have about the age and evolution of everything around us. It tells us not only that the universe once burned far hotter, but also that it has been expanding for nearly 14 billion years. The cooling is like a clock, slow, patient, precise. And every photon in the cosmic background radiates that same timeless measurement. Yet within this near uniform temperature lie tiny differences, variations of just a few millionths of a degree. These small ripples reveal where matter was once slightly denser, slightly warmer, or slightly cooler. Those subtle differences, so faint they require sensitive instruments to detect, are the seeds from which galaxies and clusters eventually grew. From the quiet temperature of the cosmos today, we can trace the first hints of structure that shaped everything we see. As you breathe gently, imagine this temperature as the universe's resting heartbeat. Calm, steady, unchanged for billions of years. A warmth that has cooled but not vanished. A glow that has faded but not died. Even now, as space continues to stretch, the background temperature keeps dropping, drifting slowly toward deeper stillness. And yet, for all its quiet cold, the cosmic microwave background is a reminder of a time when everything was once bright, once unified, once unbearably hot. A universe that has settled, a universe that remembers. If the cosmic background radiation were perfectly smooth, exactly the same temperature in every direction, the universe today would look nothing like it does. There would be no galaxies, no stars, no planets, no warm clusters of gas, no spiraling arms of starlight. Everything would be a uniform mist, spread evenly forever. But it wasn't perfectly smooth. It held tiny, almost imperceptible ripples, small temperature fluctuations only millionths of a degree apart, and those tiny differences changed everything. As you breathe gently, picture the early universe as a vast ocean of glowing plasma. Most of it was calm and uniform, but here and there, faint ripples moved across the surface, slightly warmer spots where matter clumped a little more tightly, slightly cooler spots where it spread out a little more. These variations were incredibly subtle, small enough that no human sense could ever detect them. Yet they were enough to break the cosmic symmetry. In those slightly denser regions, gravity took hold. It pulled a bit more strongly, collecting more matter, deepening the ripple. Over millions of years, those ripples grew. What began as a faint bump in temperature became a cloud. What became a cloud condensed further into the first stars. From those stars came clusters, galaxies, and the entire cosmic web that now stretches across the universe like a vast, interconnected lacework. All of that, the Milky Way, the night sky, the atoms that form your breath, began as almost invisible patterns imprinted on the cosmic microwave background. The structure of everything was encoded in those small fluctuations, waiting patiently for gravity to sculpt their potential into form. Tiny variations that became enormous consequences. These temperature differences are more than scientific curiosity. They are the universe's earliest handwriting. When astronomers map the cosmic microwave background, they see a mottled pattern of spots, some slightly warmer, some slightly cooler. That pattern is a portrait of the universe when it was only 380,000 years old, a baby picture. And in that picture you can already see the blueprint of everything that would ever exist. As you rest in the quiet, imagine that blueprint unfolding like a slow cosmic breath. Imagine each tiny ripple stretching into vast filaments of galaxies. Imagine the early hum of density becoming the architecture of the sky. The universe did not begin with chaos turning into order. It began with small differences gently guiding the flow of everything that followed. In those tiny fluctuations, the universe revealed its intention to grow, to shape, to become. Long before galaxies spiraled into being, before stars scattered their light across the darkness, the universe was already writing its story. Not in words or symbols, but in patterns, subtle, delicate variations woven into the fabric of the cosmic microwave background. These patterns formed when time itself was still learning how to flow, when the cosmos was so young that the meanings of moment, before and after, had barely begun to take shape. As you breathe slowly, imagine the earliest universe as a calm, radiant sea. On its surface, tiny ripples flickered, slight differences in temperature, density and motion, each no more than a whisper against the overwhelming brightness. Yet those whispers were not random. They carried the faint echo of earlier events, imprints of quantum fluctuations stretched across unimaginable scales as the universe expanded. These patterns became frozen into the cosmic background radiation when light was finally released during recombination. The photons captured the landscape of that moment, the hills and valleys of density, the gentle shifts in temperature, preserving them like a photograph pressed into the universe itself. Every warm spot in that ancient map marks a region where matter once gathered more densely. Every cool spot marks where matter drifted thin. Together, these marks form a tapestry of beginnings. What makes these patterns extraordinary is that they appeared before time behaved in any familiar way. In an expanding universe still smoothing itself out, forces had barely settled. Laws were forming, space was stretching, and through all of this, fluctuations danced in and out of being, sometimes amplifying, sometimes fading, until the moment light captured them forever. They hint at processes we still don't fully understand. How inflation magnified atomic scale variations into cosmic scale differences. How the universe's earliest moments sculpted the possibilities of everything to come. As you lie quietly, imagine this ancient tapestry unfolding like a soft wave across the sky. It is the oldest pattern we can observe, a blueprint etched before stars existed, before time settled into its steady rhythm. It is astonishing to realize that galaxies, clusters, planets, and life itself emerge from those faint, uneven marks. The universe didn't begin from perfect symmetry. It began from a textured softness, a gentle imbalance that allowed beauty to form. These early patterns remind us that incredible complexity can grow from the smallest seeds, that vast structures can rise from quiet irregularities. They show that the universe carries memory not just in light, but in shape. Patterns written before time had shape of its own. To see the cosmic microwave background, you don't use your eyes. Human vision is tuned to narrow bands of visible light, bright colours, and sharp contrasts. But the universe's oldest glow exists far beyond that range, stretched by billions of years of expansion into wavelengths too long and too gentle for ordinary sight. To observe it, astronomers use radio eyes, instruments that listen rather than look, detecting the soft microwaves humming through space. As you breathe slowly, imagine a telescope not as a glass lens, but as a great open ear, a dish curved to catch whispers instead of reflections. Radio telescopes listen to the faint static of the cosmos, gathering signals that arrive from every direction with equal patience. These waves are quiet, steady, and incredibly uniform. To detect them requires instruments of exquisite sensitivity, devices capable of hearing a single photon that has wandered through the universe since its earliest dawn. From the outside, these telescopes look serene, vast metal bowls resting under the sky, unmoving except for gentle rotations. But inside their receivers, the universe is alive with sound. The cosmic background radiation arrives as a soft hiss, a gentle noise layered beneath all the loud signals of modern life. It is a whisper buried under the radio chatter of Earth, yet still unmistakable when you know how to listen. Scientists often describe the CMB not as something they see, but something they measure. Its temperature is recorded with delicate precision. Its fluctuations appear as slight variations in signal strength. Each measurement becomes a pixel on a map, a point on the oldest picture we have of the universe. In this way, radio telescopes become translators, converting ancient waves into images, transforming faint cosmic murmurs into patterns we can understand. Listening to the universe in this way changes how we think about observation. It becomes less about capturing beauty and more about sensing history, less about brightness and more about patience. These waves have no sparkle, no colour, no shape, yet they carry a story older than any star. As you rest, imagine holding a small, quiet receiver in your hands. Imagine tuning out every noise on Earth, the movement of air, the hum of electricity. even the beating of your heart, until all that remains is the soft, constant hiss of the cosmos. That hiss is not interference. It is not a flaw. It is the universe speaking in its faintest voice, telling us what it was like before darkness formed, before structure rose, before time found rhythm. To listen to the cosmic background radiation is to listen to the universe remembering itself. Before modern digital signals, televisions used to display a soft, snowy pattern when tuned to an empty channel, a drifting field of black and white specks dancing in quiet randomness. To many people, it was simply static, a harmless inconvenience, a sign that the antenna needed adjusting. But hidden within that static, faint and almost forgotten, was something remarkable, a tiny fraction of the cosmic microwave background itself. When you looked at that snowy flicker, you were looking at the universe's oldest light, without even knowing it. As you breathe gently, imagine holding an old analog TV in a dark room. When the screen crackles to life without a signal, part of that restless shimmer is ancient radiation, reaching you after almost 14 billion years of uninterrupted travel. The universe was whispering through the static, a quiet reminder that even the emptiest channel contains echoes of creation. Of course, most of the noise came from Earth, electrical interference, atmospheric disturbances, imperfections in circuitry. But sprinkled among those earthly signals was real cosmic background radiation, manifesting as tiny bursts of light on the screen. The idea that a simple household device could accidentally pick up the echo of the Big Bang still feels almost magical, as if the universe left clues in the most ordinary places. This connection between static and cosmic radiation mirrors how discovery often works. Profound truths hiding inside everyday noise. Before astronomers had sophisticated satellites and ultra-sensitive detectors, the universe was already broadcasting its oldest message, waiting for someone to notice. The glow was always there, drifting in through antennas and sprinkling itself across screens like distant starlight broken into tiny pieces. The static we once saw is a reminder that the universe does not separate the extraordinary from the ordinary. Ancient photons slip into our world quietly, mixed with the hum of appliances, the rustle of signals, the background breath of daily life. Even now, if you were to listen to an untuned radio, a small portion of the hiss would still be cosmic, an artifact from the early universe sliding effortlessly into the soundscape of your room. As you relax, think of how surprising it is that something so ancient can feel so familiar. The oldest light in existence does not appear as a dazzling flare or a cosmic beacon. It arrives as a gentle hiss, a shifting pattern, a soft flicker on a forgotten screen. It reminds us that the universe's deepest mysteries often hide in the quietest moments, blending into the spaces we overlook. In the static between stations, the universe hums its earliest memory. Sometimes the greatest discoveries arrive not through grand experiments or towering telescopes, but through simple persistence, through the quiet curiosity of people trying to solve a small, stubborn problem. In the early 1960s, two radio engineers named Arno Penzias and Robert Wilson were working with a large microwave antenna in New Jersey. Their task was practical, not cosmic. They were testing communication systems, adjusting equipment, and making sure their instrument was free of interference. But what they kept hearing was a faint hiss, a background noise that refused to disappear. As you settle into deeper calm, imagine them standing beside their vast white antenna under a soft sky, listening through layers of static. They checked every connection, every wire, every surface. They removed dust, tightened bolts, and even chased away pigeons nesting inside the dish, thinking their presence might be causing the unwanted signal. Yet no matter what they tried, the hiss remained, steady, uniform, unchanging, coming equally from every direction. This persistence puzzled them. Noise usually has a source, a cause, a direction. But this hiss felt different, almost as if it belonged to the sky itself. Penzias and Wilson didn't yet know that just across town, a team of physicists led by Robert Dicke was searching for precisely this kind of signal, a remnant of the early universe predicted by the Big Bang theory. When the two groups finally connected, the pieces fell into place. The engineer's stubborn hiss was not a flaw. It was the cosmic microwave background. They had discovered the universe's oldest light without ever aiming to find it. This moment reshaped cosmology. The discovery provided strong, elegant evidence that the universe had indeed begun in a hot, dense state, and had since expanded and cooled. A signal older than any star had been captured not by deep space observatories, but by an antenna originally built for communication research. A reminder that the universe sometimes reveals itself through accidents, through unexpected persistence, through noise that refuses to be ignored. As you breathe gently, imagine that quiet hiss drifting through the air around you, unchanged since long before Earth existed. Penzias and Wilson had tuned into a cosmic memory hiding in plain sight, a message waiting patiently, whispering through atmosphere and metal, through static and dust, for someone to notice its steadiness. Their discovery teaches something simple but profound. Even the faintest signal can carry enormous meaning. Even a soft hiss can be the voice of the cosmos. Before the cosmic microwave background was discovered, the idea of the Big Bang was just one of several possibilities. Some scientists imagined a universe that had always existed, steady and unchanging, without a true beginning. Others proposed cycles of expansion and contraction, or webs of creation unfolding in ways far different from the story we know today. But when the faint hiss detected by Penzias and Wilson was recognized for what it truly was, something shifted. The universe had spoken, and its message was unmistakable. It had once been hot, dense, and glowing. As you breathe slowly, imagine the early scientific landscape as a quiet crossroads. Researchers debated models, each grounded in mathematics, each offering a different picture of cosmic origin. The Big Bang theory predicted that the universe should be filled with ancient radiation, cool, uniform, and detectable everywhere. But until the 1960s, that prediction had no physical proof. It lived in equations, not in evidence. Then suddenly the sky itself confirmed the math. The cosmic microwave background wasn't just a leftover accidental glow. It was the smoking ember of the universe's first fire. This discovery was profound because it provided a direct window into the universe's infancy. It told scientists that the cosmos had indeed expanded from a far hotter state, and that the expansion had stretched early light into the microwaves we observe today. The steady-state model, which suggested the universe looked the same at all times, could not explain this radiation. The cosmic background belonged only to a universe that had changed, one that had cooled, evolved, and carried memories from a beginning. The Big Bang theory didn't just gain support, it gained its foundation. Over time, detailed measurements of the cosmic background strengthened the picture further. Its uniformity showed that the early universe was smooth and evenly distributed. Its tiny fluctuations revealed the seeds of structure. Its spectrum matched perfectly with what theory predicted for a cooling, expanding universe. Everything aligned with the idea that the cosmos had emerged from a single, astonishing moment of birth. As you rest in the quiet, imagine the cosmic microwave background as both evidence and poetry, a scientific signal wrapped in profound beauty. It is not loud or dramatic. It is soft, patient, and everywhere. The kind of truth that doesn't rush, that doesn't fade, that simply exists. The universe carries its origin in its glow, and in doing so, it confirmed a story written long before any human looked up at the sky. Once scientists understood that the cosmic microwave background was the ancient afterglow of the Big Bang, a new question emerged. What exactly does this glow look like? For decades, the radiation was known to be uniform, smooth across the sky, like a blanket of quiet warmth. But to uncover its secrets, to see the tiny fluctuations that held the blueprint of all cosmic structure, astronomers needed clearer, more sensitive observations. They needed to map the universe as it looked in its earliest visible moment. As you breathe gently, imagine the sky transformed into a canvas, painted not with stars but with temperature variations no brighter than a whisper. This canvas is what scientists hope to capture, a portrait of the universe when it was only 380,000 years old. But such a portrait required instruments far beyond what ground-based telescopes could manage. The microwaves carrying this ancient picture were faint, delicate, and easily disturbed by Earth's atmosphere. The solution was to lift our eyes, quite literally, above the noise. In 1989, NASA launched COBE, the Cosmic Background Explorer. It drifted in space like a quiet listener, tuned to the soft hum of the universe. COBE produced the first detailed map of the cosmic microwave background, revealing minute temperature differences, just tiny ripples, but enough to astonish the scientific world. These ripples were the seeds of everything: galaxies, clusters, filaments, and cosmic webs stretching across billions of light years. COBE confirmed the universe's early irregularities, but it was only the beginning. A decade later, the WMAP satellite sharpened the view. Its maps were clearer, more precise, revealing structures in the microwave sky with startling definition. And later still, the Planck mission offered the most detailed picture ever, so sensitive it could detect fluctuations as small as a few millionths of a degree. As you rest, imagine looking at one of these maps, a swirling pattern of reds and blues, warm spots and cool spots scattered across the sky like the texture of a soft cosmic quilt. It is not random, it is not chaotic, it is structured in a way that matches predictions for inflation, expansion, and the early behaviour of matter. Each patch on the map tells a story of density, motion, gravity, and the formation of the universe's grand architecture. Mapping the cosmic microwave background was like opening an ancient book whose pages had been sealed in light for billions of years, and with each new mission the text grew clearer, revealing more of what the universe once was, its patterns, its vibrations, and its earliest whispers. Imagine the early universe as a vast glowing ocean, not of water, but of energy, heat, and particles swirling in a dense radiant tide. In this primordial sea, sound waves rolled through the plasma, compressing and expanding pockets of matter, much like waves rising and falling across a sunlit bay. These cosmic ripples, formed long before atoms or stars, left their signature on the cosmic microwave background. The same faint pattern we see today in maps drawn by telescopes like COBE, MAP, and Planck. As you breathe slowly, picture those waves gently moving through the early cosmos. They weren't chaotic or violent. They flowed with a rhythm set by the balance between gravity pulling inward and radiation pushing outward. When gravity squeezed matter into clumps, pressure pushed back, creating oscillations, like the universe itself was pulsing, inhaling and exhaling in light. These oscillations produced slight differences in temperature and density, subtle enough to escape ordinary eyes, but profound enough to shape everything that followed. When the universe cooled enough for atoms to form and light to break free, these ripples froze in place. The cosmic microwave background became a snapshot of a sea caught mid-wave. The bright spots represent compressed regions, where matter gathered tightly. The cooler spots mark areas where matter thinned. And together, these patterns reveal the cosmic symphony playing in the universe's earliest moments. What's remarkable is how faithfully these ripples predicted the universe's later structure. regions of compression eventually became clusters of galaxies. Areas of rarefaction became the vast, dark void stretching between cosmic filaments. The entire large-scale shape of the universe, the grand web of galaxies we observe across billions of light-years, emerged from the faint vibrational patterns imprinted on this primordial glow. Scientists sometimes call these acoustic oscillations, but their name hardly captures their elegance. They are the universe's first music, vibrations rippling through a plasma that had no stars to illuminate it, no planets to anchor it, no observers to hear it. And yet, these vibrations set the stage for everything that exists. As you relax, imagine floating on a calm ocean at dawn, waves gently lifting and lowering your breath. That sensation mirrors the early universe's motion, slow, rhythmic, balanced. The patterns frozen in the cosmic microwave background are the traces of that ancient rhythm, preserved with perfect stillness across time. To study these ripples is to hear the heartbeat of the cosmos when it was young. A pattern of inhalations and exhalations, written in temperature and light, carrying forward into the galaxies, the stars and the quiet night surrounding you now. Long before the universe grew spacious and quiet, it burned with a brightness no eye today could endure. The cosmos was once a furnace, so hot, so dense, so radiant that everything shimmered like a living flame. Space itself glowed. Matter glowed. Even the smallest particles pulsed with heat. The entire universe was a single, incandescent storm of energy, and cosmic background radiation is the cooled, faded memory of that fire. As your breath softens, imagine a world where the air is light itself, where every direction shines with overwhelming brilliance, leaving no room for darkness. This was the cosmos during its first few 100,000 years. Temperatures were millions of degrees. Atoms could not survive. Every photon collided endlessly with charged particles trapped like sparks in a storm. To call this a universe feels almost misleading. It had no stars, no structure, no landmarks. It was light and heat, pressure and motion, pure radiance. The earliest moments after the Big Bang were not quiet or empty. They were ablaze. Yet even in this blazing beginning, the seeds of everything familiar were forming. As the universe expanded, its fire dimmed, not because it cooled outward into something else, but because space itself stretched, dispersing the heat, softening the intensity. Like a glowing ember placed in open air, the cosmos released its brilliance slowly, steadily, naturally. This transition from fire to clarity is one of the most beautiful arcs in cosmic history. For hundreds of thousands of years, the universe radiated like the surface of a star. But as expansion continued, temperatures dropped, the furious glow settled, the cosmic plasma thinned, light, once confined, prepared to escape. And when recombination arrived, the brightness that had filled all of space finally loosened its grip. What we see today as the cosmic microwave background is the residue of that fire, light stretched and cooled until it is no longer visible, yet still perfectly uniform, still humming softly across every direction. Photons that once blazed with unimaginable energy now arrive as gentle microwaves, faint but eternal. As you rest, imagine holding a small ember in your hand, watching its colour fade from white to red to soft, dim warmth. That slow cooling reflects the journey of the universe itself, from searing brilliance to gentle glow. The universe that once glowed like fire is still glowing, but in a way so calm and so subtle that it passes through you unnoticed. The cosmic microwave background is not the fire of creation, but it is its last surviving light. The light we call the cosmic microwave background has travelled an unimaginable distance, not through empty corridors, but through a universe that has been changing beneath it the entire time. When these ancient photons first began their journey, they were bright, energetic waves, short, sharp, and hot. But as the cosmos expanded, the fabric of space stretched, and every wave of light stretched with it. Their wavelengths lengthened, their energy fell, their colour cooled. And slowly, across billions of years, what began as blinding brilliance softened into the gentle microwaves that now drift quietly through the night. As you breathe slowly, imagine holding a ribbon in your hands and pulling gently at both ends. The ribbon grows longer, thinner, more delicate. This is how cosmic expansion treats light. Space doesn't simply carry photons, it actively changes them. The universe is not a silent stage upon which light moves. It is a living field that reshapes the very radiation flowing through it. This stretching is called redshift, and it is one of the most peaceful transformations in nature. It does not tear, it does not break. It simply elongates, like a long breath released into still air. Over billions of years, the universe's expansion has redshifted the background radiation by more than 1,000 times. What once roared with the intensity of a star's surface now murmurs at a temperature just above absolute zero. The change is profound, but the process is gentle, a slow drift toward coolness. Imagine for a moment that you could watch a photon through time. At the beginning it vibrates rapidly, full of energy, bright with the heat of creation. As space stretches, the vibration slows, the wave relaxes, its colour shifts from white to red, then from red to infrared, then to microwave. The photon never stops travelling, but its identity softens. It ages, not by fading, but by lengthening, by allowing the universe's expansion to guide its transformation. This stretching carries meaning. It tells us the universe is not static, but alive with motion. It tells us that distances grow, that galaxies drift apart, that horizons widen with every passing moment. The cosmic microwave background is not simply a relic. It is a record of the universe's expansion written directly into the wavelength of light. As you rest, imagine this soft redshifting happening all around you, even now. Every ancient photon passing through your room has been shaped by the growth of the universe, stretched across time until it became a whisper instead of a blaze. You're surrounded not just by old light, but by light that has been transformed by the very history of space itself. In its stretching, the universe reveals its gentle ongoing motion. When paleontologists unearth ancient bones, they uncover physical stories from ages long gone. Silent remains, speaking of creatures that once walked the earth. Astronomers too study fossils, but their fossils are made of light. The cosmic microwave background is often called fossil radiation, not because it is old, but because it preserves a moment in time that no longer exists. It is the last visible trace of an era erased by billions of years of cosmic evolution. As you breathe slowly, imagine that every photon in the background radiation is a tiny artifact. Each one carries information about a universe that was once young, dense, and glowing, with an intensity beyond imagination. Unlike bones or stones, these fossils were not buried. They simply kept travelling, unbroken, across the vastness of expanding space. They pass through galaxies, drift through clusters, slip quietly through your room, each one a messenger from a forgotten age. This light is fossilized not because it has changed little, but because it has changed predictably. Its cooling, its redshifting, its softening, all follow the story of cosmic expansion. When we observe it, we are not seeing the universe as it is, but as it was nearly 14 billion years ago, preserved with extraordinary clarity. The photons have stretched, but the patterns imprinted on them, the tiny fluctuations, the traces of early density, remain intact. Like fingerprints pressed into soft clay, they hold the marks of the universe's first structures. Think of how rare it is to find something unchanged across such vast time. Worlds have formed and vanished. Stars have burned, exploded and collapsed. Galaxies have collided and reshaped themselves. Entire cosmic epochs have passed. Yet this fossil light drifting through it all still carries the initial imprint of the primordial plasma. As you relax, imagine the universe of that era. No stars, no planets, no galaxies. Only a glowing sea of particles and radiation. A world so alien that even imagination can barely grasp it. Yet the cosmic microwave background gives us a direct glimpse into that vanished state. It is a window not onto a place, but onto a time, one that no longer exists except in this preserved fossilized glow. The term fossil light reminds us that the universe has a memory, not a memory in words or records, but in radiation, silent, drifting, patient. It holds its past not in books or stones, but in the very photons that fill the night. Each one passing through you now is a relic from when everything was young. To most of us, noise feels like something meaningless, an unwanted blur, a background hum we try to filter out. But in the cosmic microwave background, the noise is the message. Those tiny temperature variations scattered across the sky, those faint ripples and uneven patches hold some of the deepest clues about the universe's structure, its age, and even its fate. What looks like randomness is, in truth, a coded map of how everything began. As you breathe calmly, imagine looking at a pattern of soft colours, red slightly warmer, blues slightly cooler, spread across a globe. At first glance, it might seem like nothing more than a textured wash, but hidden in its shapes are precise details. The density of early matter, the composition of the universe, the strength of primordial gravitational ripples. Each fluctuation tells a story. Scientists read these patterns the way geologists read layers of rock, or musicians read musical scores. The temperature differences, only a few millionths of a degree, reflect where matter was gathering and where it was thinning. From this, researchers can tell how much of the early universe was made of normal matter, how much was dark matter, and even how much was dark energy. The cosmic background radiation is a treasure chest of clues disguised as static. These clues also reveal the age of the universe with incredible accuracy. By analysing the scale of the temperature variations and how they align across the sky, scientists determine how fast the universe expanded, how quickly structures formed, and how long cosmic evolution has unfolded. The conclusion: the universe is about 13.8 billion years old. A number not guessed but measured, derived from patterns faint as a whisper. Even the overall geometry of the cosmos, whether space is curved, flat, or bent into something stranger, is encoded in these ripples. The angles at which the fluctuations appear tell us that the universe is remarkably flat, extending smoothly in all directions without noticeable curvature across cosmic scales. A single snapshot of faint, seemingly random noise reveals the shape of space itself. As you rest, imagine holding a parchment covered in characters you cannot read, yet knowing that those markings contain the history of an entire world. The cosmic microwave background is like that, dense with meaning, delicate in structure, speaking through variations far too subtle for our senses. What seems like noise is not noise. It is the universe whispering secrets through temperature and light. It invites us to listen closely, to notice patterns, to recognize meaning in the faintest fluctuations. In its quiet texture, the cosmos hides its deepest truths. If you wanted to know the shape of the universe, not its objects but space itself, you might imagine travelling outward in a straight line, wandering past stars and galaxies until you felt some curve or boundary. But the universe is far too vast for such a journey, and its shape is far too subtle to sense through motion alone. Instead, we learn the shape of everything by reading the faint patterns of the cosmic microwave background. The universe has drawn its geometry into that ancient glow. As your breath settles into a slow rhythm, imagine the sky as a great sphere surrounding you, painted with tiny temperature variations. These fluctuations act like markers, cosmic signposts indicating how light travelled through space shortly after the Big Bang. If the universe were curved like a saddle, those patterns would distort in one way. If it were curved like the surface of a sphere, they would distort in another. But the patterns appear just as they would in a flat universe, one where space extends smoothly, endlessly, without significant curvature across the larger scales. This discovery is astonishing because flatness is not something the universe naturally drifts into. It requires balance, a near-perfect equilibrium between the energy that would cause space to curve and the expansion that stretches it outward. The cosmic microwave background shows that this balance was present from the earliest moments, preserved through the expansion like a signature pressed into soft clay. Scientists measure the angular sizes of the fluctuations, the way warm and cool spots appear on the sky. If the universe were closed and curved inward, the spots would look larger. If it were open and curved outward, they would appear smaller. But they are just the right size, matching the predictions for a universe that is geometrically flat. In these patterns, the cosmos quietly reveals that space behaves like a vast, even plane. As you rest, imagine floating on a calm, endless surface. No edges, no slopes, no boundaries. That is the nature of cosmic flatness. We are not inside a bubble or sitting atop a cosmic hill. We drift through a space that extends uniformly in all directions, steady and balanced. This shape does not dictate where galaxies form or how stars shine, but it provides the stage upon which all cosmic evolution unfolds. The shape of the universe is not something we can see with eyes or feel with touch, but it is written delicately into the glow that surrounds us, the oldest light, carrying the geometry of existence itself. In this faint radiation, the cosmos whispers, "I am vast, I am balanced, I am open." The universe revealed its shape not through motion, but through memory, through a glow that has never faded. Before the universe became the smooth, expanding cosmos we know, it passed through a moment so brief and so powerful that its effects still echo through the cosmic microwave background. This moment is called inflation, a sudden, exponential expansion that occurred a tiny fraction of a second after the Big Bang. Though impossibly fast, inflation left fingerprints everywhere, including in the delicate ripples of temperature we observe in the ancient glow. As your breath settles, imagine the early universe no larger than a grain of dust, then suddenly stretching to cosmic scales in an instant. In that moment, any irregularities that existed were smoothed out, stretched like paint pulled across an enormous canvas. Quantum fluctuations, once smaller than atoms, were expanded to the size of galaxies. These minuscule variations became the seeds of structure, the tiny differences that gravity would later amplify into stars, clusters, and the grand cosmic web. Inflation explains why the cosmic microwave background is so uniform across the entire sky. Without it, distant regions would never have interacted, never had time to equalize temperature or exchange energy. But inflation connected the whole cosmos in a single, swift motion. It stretched space so quickly that areas now separated by billions of light years were once close enough to share the same conditions. The uniform glow of the CMB is a calm reminder of this astonishing event. But inflation also left subtle imprints. The size distribution of the fluctuations, the way warm and cool spots appear across the sky, matches the predictions of inflation almost perfectly. The slight tilt in the power spectrum, the scale dependence of the ripples, even the smoothness of the large-scale map all point back to this rapid primordial expansion. The cosmic microwave background is not just evidence of the universe's birth, it contains the echo of the moment it took shape. As you rest, imagine listening to a distant drum beat, softened by time but still present in the air. Inflation is that drum beat, a deep, ancient pulse resonating through the structure of space. The patterns in the CMB are the lingering vibrations of that pulse, carried across billions of years by photons that never lost their memory. Though inflation happened in less than a trillionth of a second, its effects define the universe we inhabit. Space is flat because of it. Structure exists because of it. The cosmic microwave background glows with its signature. Inflation shaped the universe with a single, swift exhalation, and that breath still echoes in every direction. In the oldest light, we feel the faint trace of the universe's first heartbeat. If the early universe truly passed through the rapid expansion of inflation, then it may have done something extraordinary, something we are still trying to detect today. Inflation would have shaken the fabric of space itself, sending out tiny gravitational waves rippling through the newborn cosmos. These waves were not like the ones produced by colliding black holes or merging stars. They were softer, older, woven into existence at the very moment the universe took shape, and if they exist, they would have left their imprint on the cosmic microwave background. As you breathe gently, imagine space behaving like a calm lake. Inflation was a sudden stone dropped into that lake, creating ripples that spread in all directions. These ripples were not waves in water, but waves in space-time itself, stretching and squeezing space on scales too vast and too subtle for our senses. But the ancient photons of the cosmic microwave background may have recorded that stretching. They might carry traces of those primordial waves in patterns of polarization, a faint swirling signature written into the glow. Scientists search for these signals by studying the polarization of the CMB, specifically a pattern called B-mode polarization, a subtle twisting of the microwave light. If detected cleanly, it would be like hearing the faint echo of the universe's first shaking, a direct clue to inflation's dramatic opening. It would be evidence not just of how the universe expanded, but of how space itself behaved when everything began. Early hints of such signals have appeared, sparking excitement and debate. Some observations suggested a swirling pattern that looked like the imprint of primordial gravitational waves, but later studies show that interstellar dust, microscopic grains floating through our galaxy, could produce a similar pattern. The universe whispered, but the whisper was tangled with nearer noise, and so the search continues, growing ever more delicate. As you rest, imagine astronomers listening to the quietest tremor imaginable, one that began billions of years before stars, planets, or life. They build instruments on mountaintops, on balloons drifting above the atmosphere, even on satellites orbiting Earth, all trying to separate the true cosmic signal from the dust and noise of our own galaxy. Their work is a study in patience, in gentleness, in seeking clarity without disturbance. If we someday detect these primordial waves, it would be like opening a door directly into the first trillionth of a second after the Big Bang. Not light from that era, light didn't exist yet, but motion, the trembling of space itself, a message older than atoms. Even without the final answer, the search teaches something profound. The universe carries its beginnings not only in light but in motion, in the quiet ripples that may still drift through the fabric of existence. Among the soft, mottled patterns of the cosmic microwave background, one region stands out, a patch of sky cooler than the rest, wider than expected, quieter than theory comfortably predicts. This region is known as the cold spot, a subtle dip in temperature that has puzzled cosmologists for decades. Most fluctuations in the CMB fit neatly into statistical expectations, tiny ripples formed by early density variations. But the cold spot is different. It is larger, deeper, and quieter than the surrounding cosmic texture, as if the universe took one long, unusual breath in that direction. As you breathe gently, imagine looking at a map of the ancient sky. Warm reds, cool blues, swirling softly like watercolour, and then noticing one area where the colour sinks into a deeper calm. This is the cold spot. It isn't freezing or dark, it is simply cooler by a small fraction of a degree. But in the exquisitely precise world of cosmic background radiation, that small difference carries weight. Scientists have proposed many explanations. Some believe it could be a statistical anomaly, a rare fluctuation that just happens to fall outside the normal pattern. Others think it might be a clue to something more mysterious. One idea suggests that the cold spot is the imprint of a massive cosmic void, a region of space with fewer galaxies, less matter, and therefore a different gravitational influence on passing photons. As light travels through such a void, it loses a bit of energy, arriving cooler than expected. This explanation is gentle, natural, and rooted in known physics, but some theories reach further. The cold spot has sparked speculation about exotic possibilities, evidence of a collision between our universe and another within a larger multiversal sea, a remnant of early cosmic defects, or some imprint left by physics that existed before inflation stretched the cosmos smooth. These ideas are not confirmed. They remain whispers, possibilities, questions without clear answers. Yet the cold spot invites them, because it sits just far enough outside expectation to spark imagination. As you lie quietly, consider how peaceful the anomaly truly is. It does not break the map. It does not distort the universe. It is simply a soft deviation, a slightly deeper blue in a sky painted with ancient light. And perhaps that is why it feels so poetic. Even in a universe defined by harmony and balance, there is room for subtle irregularities, for gentle surprises. The cold spot reminds us that the universe still holds secrets, hidden not in distant galaxies or exotic matter, but in the quiet temperature of the oldest light. A small deviation in a vast sky, inviting curiosity without urgency. In its coolness, the cosmos leaves a question open, waiting patiently for us to listen. When we picture the universe expanding, it is tempting to imagine a blast, an explosion with a central point from which everything rushes outward. But the cosmic microwave background tells a different story, one far more subtle and elegant. Its uniform glow, spread evenly across every direction, reveals a profound truth. The universe has no center in space. Every point is expanding away from every other point, not from a single origin, but from a state where all of space was once compressed together. As your breath softens, imagine standing on the surface of a vast balloon. If the balloon inflates, every spot on the surface moves away from every other spot. There is no special place where expansion begins. The stretching happens everywhere at once. This is how space behaves. The galaxies drift apart, not because they were thrown from a central explosion, but because the space between them expands uniformly. The cosmic microwave background confirms this deeply. No matter where you look, no matter where you stand, the temperature of the ancient glow is nearly identical. There is no direction where it suddenly brightens, no place where it fades into emptiness. This symmetry shows that the Big Bang happened not at a point in space, but as an event that occurred everywhere at the same time, when the entire universe was compressed into a state of extraordinary density. If the universe had a center, the CMB would tell us, one side of the sky would appear hotter or denser, the opposite side would cool or thin out. Instead, we see calm consistency. The same glow surrounds us, embracing us with the same ancient whisper it offers to galaxies billions of light years away. If an observer on a distant world looked at the cosmic microwave background, they would see almost the same map we see, almost the same temperature. They would believe themselves to be at the center too, and in a sense they would be right. Every place in an expanding universe feels like the center because the expansion is not outward, but everywhere. As you rest, imagine drifting in a calm sea that stretches endlessly. No shore, no origin, only gentle waves expanding around you. The universe is not pushing us away from anything. It is stretching us apart with the same quiet motion filling all of space. The CMB carries this message in its smooth glow, teaching us that centrality is an illusion born from perspective. There is no privileged position in the cosmos, no place more middle than another. We are part of a vast, evenly unfolding fabric, a universe with no center, only expansion. In its perfect symmetry, the ancient light invites us to feel at home anywhere in the cosmos. Light does not think, and yet it remembers. It carries no thoughts, no emotions, no stories written in words, yet it preserves the past with a faithfulness nothing else in the universe can match. The cosmic microwave background is the finest example of this quiet memory. Each photon in that ancient glow has travelled across almost 14 billion years without forgetting where it came from, or what the universe looked like at the moment it first set out. As your breath eases into a slow rhythm, imagine holding a tiny bead of warm light in your hands. Inside it lives a memory of an era so distant, so unfamiliar, that even imagination strains to picture it. The universe was young, glowing, filled with plasma and heat. And when the first atoms formed, when the fog lifted and light escaped, these photons began their endless journey. They have passed untouched through the births and deaths of countless stars, through the formation of galaxies, through epochs of expansion and cooling. After all that time, they arrive here, brushing softly against you. What they carry is not a detailed image, but a pattern, a record imprinted in the faint variations of their temperature and direction. These patterns reveal where matter was gathering, where density fluctuated, where waves of compression once rolled through the early cosmos. They show us how smooth the universe was, how gently uneven, how orderly yet filled with potential. They are memories of a time before structure, before darkness, before the first star pierced the quiet. Light does not choose what it remembers. It simply continues forward, unchanged except for the stretching caused by expansion. It is as if the universe encoded its earliest conditions into these photons, trusting that billions of years later, someone would learn how to read them. And we have. We decode their temperature maps, analyze their polarization, interpret their ripples. From these fragile clues, humans have reconstructed the earliest chapters of existence. As you rest, consider how unusual this is. Most things erode, most memories fade, planets crack, stars collapse, galaxies collide, but the cosmic microwave background remains steady, patient and faithful. Its photons have not decayed or scattered in any meaningful way. They do not distort or rearrange. They glide through the cosmos with the calm persistence of a breath drifting through cold air. To think of light as memory is to understand the universe as a storyteller, one that does not speak, but reveals itself through patterns preserved across eons. The CMB is a record written not on stone or paper, but on radiation itself, stored in the very wavelengths filling the sky. Light remembers so that we can understand, and in its memory, the universe keeps its earliest truth. Light is often described as eternal, immutable, a traveller that moves at the universe's ultimate speed, untouched by time. And yet, the cosmic microwave background shows us that light can change profoundly. It can age, not in the way living beings do, but in a gentler, more graceful manner. It ages by stretching, by cooling, by surrendering its youthful energy to the slow expansion of space. In that transformation, light reveals something beautiful, that aging is not decay but evolution. As you breathe softly, imagine a bright newborn photon vibrant with energy, its wavelength short and sharp like a musical note played at high pitch. This is how the universe's earliest light began, radiant, intense, impossibly hot. But as space expanded, the photon's wavelength began to lengthen. The note softened. What once was ultraviolet brilliance drifted into visible glow, then into infrared warmth, and eventually into the microwave hum we observe today. This gentle stretching is the universe's way of telling time. Light does not grow dim by burning out, it grows calm by travelling. The farther it goes, the more space expands beneath it, and the more space expands, the more the photon stretches until its colour becomes something entirely new. It is not losing itself, it is becoming part of the universe's long unfolding rhythm. The cosmic microwave background is a perfect example. These ancient photons have been travelling for nearly 14 billion years, and in that span they have lengthened by a factor of more than 1,000. They were born in a world glowing like fire, and yet they arrive now as gentle microwaves, cool and soft, carrying the memory of that lost era in a quieter tone. To age for light is to transform without breaking, to remain what it is, yet shift into a new expression. As you rest, imagine light aging around you. Photons passing through your body at this moment are older than stars, older than the Milky Way, older than the earth beneath you. They do not rush, they do not tire. They change only because the universe has stretched their path, guiding them gently into longer, slower vibrations. This aging of light is not a flaw or a fade. It is a testament to the universe's expansion, a cosmic clock that records both distance and time. Each redshifted photon is a note in the universe's long symphony, deepening as the melody unfolds. The cosmic microwave background is the oldest, calmest chapter of that melody. A light that has aged into stillness, and in doing so, become easier to listen to. When we look at the cosmic microwave background, we're not just observing ancient light, we're looking at the universe's first visible moment. In a sense, the CMB is the oldest photograph ever taken, a snapshot preserved not on paper or film, but on radiation that has been travelling unbroken since the dawn of clarity. It captures the cosmos when it was only 380,000 years old, an infant compared to the nearly 14 billion years that followed. As your breath settles into a gentle rhythm, imagine opening an album of family memories and finding a picture from the very first days of a child's life. The features are soft, the shapes not yet defined, but the essence is unmistakable. That is what the CMB represents for the universe. A baby picture filled with hints of everything the cosmos would eventually become. The photograph was not taken with a camera. It was created the instant the hot plasma of the early universe cooled enough for atoms to form. Before that moment, light could not travel freely. Every photon was scattered, bounced, redirected by charged particles. But when atoms formed, the fog lifted and photons streamed outward, free for the first time. That release froze the universe's appearance in place, imprinting its density, its ripples, its first structure onto the radiation that still surrounds us today. This ancient image shows a universe without stars, galaxies, or planets. Instead, it reveals a mottled landscape of temperature variations, slightly warm patches where matter was gathering, slightly cool patches where it thinned. These tiny differences, barely perceptible, hold the blueprint of all cosmic architecture. The great cosmic web, the galaxies spiraling with starlight, even the molecules that would one day form life, all of it can be traced back to the structure captured in this earliest picture. As you relax deeper, imagine holding this cosmic photograph gently in your mind. Its colours are not truly reds and blues, but temperature shifts. Its patterns are not artistic strokes, but the fingerprints of gravity and early motion. And yet, looking at it evokes a kind of quiet awe. We are glimpsing the universe before complexity, before beauty, before time had unfolded enough to weave the stories we now live inside. Unlike human photographs, the CMB has not faded with age. The light has stretched, cooled, softened, but the image remains intact, preserved by the very emptiness it has crossed. It is a picture no camera could ever retake, no memory could ever replace, no story could ever fully convey. The oldest photograph ever taken is not of a face, or a landscape, or a moment in human time. It is a portrait of the universe itself, its first calm breath, captured in light. When we think of signals from the cosmos, we often imagine dramatic events, supernova explosions, pulsar beacons, swirling nebulae. But the cosmic microwave background is nothing like these. It is not loud. It does not flash or pulse or announce itself with force. It is quiet, astonishingly quiet. A nearly perfect uniform glow spread like a whisper across all of space. And yet, in that silence, it speaks more clearly than almost anything else in the universe. As your breath softens, imagine entering a vast hall where every loud sound has faded away, leaving only the faintest hum. In that hum, patterns begin to form, gentle hints of structure, subtle rises and falls. The CMB is like that hum. It is the universe speaking in the lowest possible voice, sharing its earliest memories not through brightness, but through steadiness. This silence is meaningful because the cosmic background radiation is so calm, so uniform, the tiny deviations within it become deeply significant. A slight warm patch here, a slightly cool patch there. Each one tells us about density variations, about the forces at play in the first seconds of the universe, about how matter would later gather into stars and galaxies. The silence provides the contrast that makes the message readable. Without it, the fluctuations would be lost in noise. The CMB also speaks through its spectrum. When scientists measure the energy of its radiation, they find a nearly perfect black-body curve, the smoothest, most precise one ever observed. No star, no flame, no object on Earth produces a spectrum so clean. It is like hearing a perfectly tuned note held steady for billions of years. This quiet perfection tells us the universe was once in thermal equilibrium, bathed in uniform warmth before expansion stretched and cooled everything. And the silence reveals something else. The universe has no preferred direction. The glow does not tilt or flare. It does not reveal any cosmic north or centre. In the stillness, we learn that the cosmos is isotropic, the same everywhere, at least on the grandest scales. This quiet symmetry is a clue to the deep physical laws that shaped everything. As you rest, imagine lying beneath a soft blanket of silence, dotted only with the faintest glimmers of meaning. In that stillness, the universe becomes readable. Its earliest intentions emerge, not through drama, but through calmness. The cosmic microwave background teaches us that silence is not emptiness. It is a form of clarity, a gentle stage upon which the universe can whisper its truths without distraction. Sometimes silence speaks loudest. Sometimes the quietest signal carries the largest story. In the beginning, the universe expanded with fierce intensity. Too hot, too dense, too turbulent for anything resembling calm. But over time, as space stretched and temperatures fell, the cosmos began to soften. It began to slow. It began, in a poetic sense, to breathe. The cosmic microwave background captures this transition, a moment when the universe shifted from blazing chaos into gentle rhythm, when energy settled and structure began to emerge. As your breath eases into a steady flow, imagine the early cosmos as a single rapid inhale, an expansion so abrupt and overwhelming that nothing could form, nothing could stabilize. Light was trapped, matter was restless, space changed faster than any structure could arise. But as the universe grew, its pace eased. The wild expansion smoothed into something calmer, more predictable. It was as if the cosmos exhaled, releasing tension it had carried since its explosive birth. This shift is embedded in the CMB. The uniformity of the glow shows that the universe smoothed itself remarkably well, ironing out violent contrasts and allowing temperature to settle across unimaginable distances. The tiny ripples in the map, the warm spots and cool spots, show the universe finding its rhythm, balancing gravity with pressure, allowing waves to move through the early plasma like breaths across water. These oscillations, frozen into the CMB, are often described as acoustic waves, sound like vibrations in the primordial plasma. They rose and fell, compressed and expanded, echoing through the young universe long before atoms or stars existed. In this sense, the cosmos literally resonated. It had a pulse, it had a rhythm, it was learning to breathe. When light finally broke free at recombination, the universe entered its first quiet phase. The radiation escaped, the plasma settled, and matter could start gathering under gravity's gentle pull. Galaxies would one day form from this calm restructuring, from the universe's newly acquired ability to hold itself together without being torn apart by heat or pressure. As you rest, imagine lying beside a vast sleeping giant, feeling the slow rise and fall of its breath. That rhythm is reflected in every galaxy cluster, every filament of the cosmic web, every large-scale structure in the universe. Today's calm was built on yesterday's balance. The breath of the cosmos shaped the world you inhabit. The phrase, "the universe learning to breathe," is poetic, but the physics behind it is real. The transition from violent expansion to steady growth, from opaque fire to transparent space, from chaotic motion to organized structure. The cosmic microwave background is the imprint of that transition, an image of the universe taking a long settling breath. In its faint patterns, we witness the moment the cosmos shifted from raw energy into a place where beauty could form. There is a poetic paradox at the heart of the universe. Darkness did not exist at the beginning. In the earliest moments, space itself glowed with overwhelming brilliance. Every particle, every wave, every motion burned with radiant heat. The universe was too bright to have shadows, too hot to allow darkness to form. But as expansion cooled the cosmic plasma and the first atoms settled into place, something extraordinary happened. For the first time, light was allowed to travel freely, and for the first time, the universe became dark. As your breath softens, imagine watching a fog lift at dawn. In the early light, the entire horizon glows, diffused and hazy. No clear shadows, no true darkness. But as the fog thins, rays begin to pass through uninterrupted, revealing both brightness and shade. In the young universe, recombination played this role. When atoms first formed and the cosmic fog cleared, photons streamed outward in all directions, leaving behind no new light source. The glow that filled everything began to stretch and dim. With nothing to replenish that brilliance, the universe gently slipped into shadow. This darkness was not emptiness, it was possibility. Once the cosmic background radiation was free to travel, the universe no longer blazed with its own internal light. Instead, space cooled and dimmed, preparing a silent stage for the first stars. For hundreds of millions of years, the cosmos existed in this twilight-like state, filled with matter, filled with potential, but lacking any pinpoints of new illumination. Astronomers call this period the Cosmic Dark Ages, a time when hydrogen and helium drifted in vast clouds, waiting for gravity to gather them into the first sources of new brilliance. What we see today as the CMB is the last glow before that darkness began, a farewell flash of the bright universe that came before. It is the lingering warmth of a cosmos transitioning from fire to stillness. Darkness was not an absence but an opening, a pause between one era of light and the next. As you rest, imagine that moment of transition, the glow fading, the universe quieting, the stage clearing for future stars. The first true night in the cosmos was peaceful, calm, almost meditative. In that darkness, structure began its slow assembly. Gravity had space to work. matter could settle, the universe prepared itself for creation, not from chaos, but from quiet. When darkness became possible, the cosmos gained room to grow. Stars would soon ignite, galaxies would bloom, but for a time there was only soft, expansive shadow, and the faint memory of the light that came before. Most light in the universe comes from something. The burning heart of a star, the heat of a planet, the collision of particles, the glowing aftermath of an explosion. Light has origins, sources, and moments of creation, but the cosmic microwave background is different. Its source is gone, not destroyed, but transformed so completely that nothing resembling it remains, and yet the light persists. It has outlived the world that produced it. As your breath settles into a calm rhythm, imagine a lantern whose flame has long since cooled, but whose glow continues to drift outward across a quiet landscape. That lingering glow is the CMB. It was born in an era when the universe itself was the lantern, hot, dense, glowing from within. When atoms formed and the fog cleared, that glow streamed outward. But unlike the light of stars, it was never refreshed, never relit. It simply began its journey and never stopped. The plasma that produced this light no longer exists. It condensed into atoms, which later gathered into stars, galaxies, and every structure we know. The universe that once shone like a cosmic furnace is now vast, cool, and filled with spaces where no light naturally shines. The CMB is the only surviving evidence of that incandescent beginning, yet the light retains its imprint. Despite billions of years of travel and transformation, it still carries the faint ripples of density, the memory of early vibrations, the record of a world long dissolved. Its wavelengths have stretched 1,000-fold, cooling from white-hot brilliance into gentle microwaves. But the information remains. It is as if the universe engraved its earliest patterns into these photons, trusting them to carry that message across eternity. Think for a moment how unusual this is. Stars are born, shine, and fade. Galaxies collide and reshape. Even atoms rearrange themselves in endless cycles. But the photons of the cosmic microwave background continue uninterrupted. They neither scatter significantly nor decay. They are the universe's most faithful travellers. As you rest, imagine this old light drifting past you in infinite streams, soft, invisible currents crossing every corner of space. You're touched, in this very moment, by radiation older than any structure around you. Light that outlived not just its source, but the entire phase of existence that created it. This is what gives the CMB its power. It is not merely old, it is enduring. It is the last whisper of the first glow, preserved in motion rather than matter. Light that outlived its source reminds us that some beginnings never fully fade. They stretch, soften, and continue, quietly illuminating the present with echoes of the past. If the universe could sing, its first song would not be loud. It would not thunder or ring with clarity. Instead, it would sound like the softest lullaby, steady, gentle, almost imperceptible. The cosmic microwave background is often described in scientific terms, but in a poetic sense, it is the universe's oldest lullaby. A hum that has drifted across billions of years, filling every corner of space with the same calm, persistent note. As your breath settles, imagine lying beneath a vast night sky, listening to a faint vibration just below hearing, so soft you can only sense it through stillness. That vibration is real. The early universe was full of sound-like oscillations, pressure waves rippling through the hot plasma before atoms formed. When the universe became transparent, those waves froze into the patterns we see in the CMB today. The fluctuations in temperature and density are the lingering echoes of that primordial music. In this way, the CMB is like a cosmic lullaby carried forward in time. It is not music in the human sense, no melody, no rhythm we can directly hear, but it holds the imprint of ancient motion. Researchers sometimes imagine converting its patterns into sound, translating temperature variations into tones. The result would be a deep, slow chord, humming steadily through time, a sound that began before stars existed, before galaxies took shape, before time flowed in any familiar rhythm. What makes this lullaby remarkable is its constancy. Unlike stars that flare and fade, unlike galaxies that collide and deform, the CMB remains stable. Its note does not change. Its temperature cools slowly as the universe expands, but its pattern remains faithful to the moment it was born. It is a song that never ends, a steady reminder of the universe's earliest breath. As you rest, imagine this hum passing through you, not with force, not with sound you can hear, but with gentle presence. Every photon in the CMB carries part of that ancient vibration. When they stream through your room, through your body, through the atmosphere and beyond, they bring the memory of that lullaby with them, a soft, continuous reminder of creation's earliest motion. In the stillness of night, when the world grows quiet, the universe's faint music becomes easier to imagine. A calm chord stretched across time, a lullaby woven into the background of existence, a reminder that even in its earliest moments, the universe knew how to rest, how to resonate softly, how to drift into balance. The cosmic microwave background is that lullaby, a gentle hum that has never stopped singing. If your ears could listen not just to air, but as space itself, if they could hear the vibrations woven into the very structure of the cosmos, then the universe would sound nothing like we expect. It would not roar or crackle or ring with sharp tones. Instead, it would speak in deep, stretched out whispers. And the oldest of these whispers lives in the cosmic microwave background. If the universe had a voice when it was young, this is the echo of what it once said. As your breath softens into an easy rhythm, imagine translating the CMB's temperature patterns into sound. Warm spots become slightly higher tones. Cool spots slip into deeper notes. The resulting music would be slow, resonant and incredibly low, far below the range of human hearing. It would feel less like a melody and more like a steady presence, a vibration that passes through rather than around you. Scientists who attempt such translations often describe it as a single, rounded chord sustained for hundreds of thousands of years. This makes sense because in the early universe, pressure waves rippled through the plasma like sound waves through air. These oscillations were the cosmos's first articulations, its earliest form of expression. When the universe became transparent, these waves froze into place, and the CMB preserved them. Today, when we examine its subtle fluctuations, we are essentially looking at the fossilized shape of those early sounds. But if you could truly hear them, the experience would be surprisingly soothing. No turbulence, no staccato bursts, just long, slow pulses, like the deep chanting of an ancient choir stretched across unimaginable time. The universe's earliest motions were repetitive, rhythmic, almost meditative. In that sense, the cosmos was humming itself into structure. As you rest, imagine placing your hand on the surface of a sleeping giant, feeling a faint vibration beneath your palm. You cannot hear the sound directly, but you sense its power and constancy. That is what the CMB represents, a vibration you cannot hear but can still feel through knowledge, through imagination, through quiet awareness. If humans could hear the universe, perhaps we would find that its earliest voice was not loud or violent, but calm, a voice that matched the slow expansion of space, the gentle formation of atoms, the settle-in of the first patterns. A voice of patience, not urgency, a voice of balance. The cosmic microwave background is this voice translated into light. a record of ancient oscillations preserved not in sound waves but in temperature ripples. It is the universe's first attempt at communication, carried silently across nearly 14 billion years. If you could hear the universe, you would hear its beginning as a deep, quiet breath. Every star you see, every planet beneath your feet, every cell in your body, all of it emerged from tiny fluctuations in the earliest universe. The cosmic microwave background contains these fluctuations preserved like delicate embroidery, stitched into the glow that fills the sky. If you follow those threads backward through time, they lead to a profound realization. Everything is connected by the same ancient fabric, woven from the same primordial variations. As your breath settles, imagine looking at a tapestry from a great distance. Up close, you see only threads, thin, subtle, almost insignificant. But step back, and those threads form patterns, images, landscapes. The universe works in a similar way. Each tiny temperature difference in the CMB, each faint ripple, is a thread. Alone, it seems meaningless. But together, they form the structure of the entire cosmos. Without these variations, gravity would have had no foothold. Matter would not have gathered. No galaxies would have formed. No stars would have burned. No planets would have cooled. No life would have emerged to wonder about any of it. The entire story of the cosmos, its architecture, its evolution, its beauty, depends on these ancient threads laid out in the CMB. What's poetic is how small these fluctuations truly are. Differences of just a few millionths of a degree created everything we know. These tiny imbalances allowed matter to accumulate in some places and drift away from others. Over billions of years, those faint preferences blossomed into the vast cosmic web that stretches across space. Filaments of galaxies, clusters bound by gravity, empty voids expanding between them. It all began with threads finer than imagination. As you rest, imagine holding one of those threads gently between your fingers, a faint line of warmth from the early universe. That thread connects you to the first particles, to the first atoms, to the first ripples that moved across the newborn cosmos. It connects you to the galaxies overhead, to the stars just now forming in distant nebulae, to the entire history of cosmic evolution. This connection is not metaphor alone. It is physical. The matter in your body was shaped by the same density variations mapped in the CMB. The atoms that form your breath follow patterns set in place before the first star existed. You're not separate from the universe's earliest conditions, you're a continuation of them. The cosmic microwave background is more than old light. It is the soft thread connecting all things, from the smallest fluctuation to the grandest structure, to you. Most light in the universe has a story shaped by direction. Starlight streams outward from blazing cores, supernova flashes burst from dying suns, even the glow of galaxies flows along spiraling arms and drifting clusters. But the cosmic microwave background is unlike them all. It is a light that never chose a direction. When it was released, it expanded uniformly, moving outward from every point in space at once, not radiating from a star but from the entire universe. And because of this, it surrounds us equally, embracing every horizon with the same quiet glow. As your breath settles, imagine standing in a field during a misty dawn. The light isn't coming from a single point. It seems to rise from everywhere at once, diffused and gentle, without sharp shadows. That is how the CMB behaves. It does not cast shapes or highlight edges. It simply exists, spread smoothly through all of space. No matter where you look, the glow is there. No matter where you turn, it greets you with the same faint warmth. This uniformity is meaningful. It is one of the clearest signs that the early universe was astonishingly smooth, evenly distributed before gravity began sculpting structure. The CMB's evenness tells us that temperature, energy, and density were almost perfectly balanced. Tiny fluctuations existed, just enough to seed galaxies, but the overall field of light was remarkably consistent. It also teaches something subtle but profound. There is no privileged vantage point in the cosmos. No center, no special direction, no cosmic front or back. Every observer, whether on Earth or in a distant galaxy, sees the same ancient glow enveloping them. Each one would feel as though they stand in the middle of the universe, simply because the light behaves as though it came from everywhere. As you rest, imagine drifting in a quiet ocean where the water touches you gently from all sides. There is no current guiding you, no wave carrying you in a particular direction, only calm, surrounding presence. That is the nature of the CMB, a soft, directionless glow that holds the imprint of the young universe in perfect balance. This behaviour also reveals the nature of expansion. Space itself stretched uniformly. There was no outward blast, no singular point of origin flinging matter into emptiness. The universe expanded from within, growing like a rising loaf of bread, with every point moving away from every other. The CMB was carried along with that expansion, becoming the faint, omnipresent glow we see today. The light that never chose a direction reminds us of something comforting, that we are not on the edge of creation, nor separated from its heart. We float in the same ancient light as every galaxy, every star, every possible world. There is a gentle truth hidden in the cosmic microwave background. The universe did not begin fully formed. It began with intentions, subtle hints, faint possibilities, tiny imbalances that would one day bloom into galaxies, stars, planets, oceans, and eventually minds capable of reflecting on all of it. When we study the CMB, we're not just looking at what the universe was, we're looking at what it wanted to become. As your breath falls into a slow rhythm, imagine the early universe as a quiet field before sunrise. The shapes of hills and valleys are hinted at beneath the dim light, not yet visible but already present. The CMB is like that dim pre-dawn glow. It reveals the universe's earliest contours, where matter would gather, where emptiness would open, where gravity would sculpt threads of structure across billions of light years. What's remarkable is how small these initial variations were. Tiny fluctuations, mere millionths of a degree, determined whether a region would form a galaxy cluster or a great cosmic void. The universe did not begin with grand architecture, it began with whisper-soft suggestions. And yet those suggestions were enough. Gravity amplified them, shaping the cosmos according to the faint blueprint encoded in the background radiation. In this sense, the CMB is a map not of what the universe had achieved, but of what it was heading toward. It is the origin of potential, the first sketch of a cosmic story not yet written. Stars were implicit in those early ripples. So were planets. So were the chemical elements that would one day breathe life into growing worlds. Every moment you experience now, every breath you take, traces its lineage back to those subtle temperature fluctuations frozen into the ancient glow. As you rest, imagine holding a seed in your hands. The seed is small, quiet, unassuming, but inside it lives the entire plan for a tree, the shape of its branches, the colour of its leaves, the length of its life. The CMB is the universe's seed. Every structure we see, spiral galaxies drifting like pinwheels, clusters bound by invisible dark matter, threads weaving the cosmic web, was contained in those earliest ripples. There is something deeply comforting in this idea. The universe did not stumble into beauty. It carried the potential for beauty from the very beginning. The CMB is not a chaotic aftermath, it is a promise. A soft, ancient whisper saying, "This is what I will become," and over billions of years the universe fulfilled that promise. It grew luminous, it grew structured, It grew capable of knowing itself through beings like you. In the faint glow of the CMB, we see not just the past, but the intention of everything that followed. Early in this journey, we asked a simple but profound question. Why does the universe remember its own beginning? After travelling through the history held in the cosmic microwave background, its glow, its ripples, its whispers, we can return to that question with deeper calm and deeper understanding. As your breath settles gently, imagine the universe as a vast being taking its first conscious look at itself. The CMB is that first reflection, a mirror capturing how the cosmos appeared in its earliest moment of clarity. But unlike ordinary mirrors, this one does not fade. It follows the universe everywhere, imprinted not on glass but on radiation drifting through all of space. The universe remembers because light remembers, and light remembers because it never stops moving. This ancient glow tells us what the early cosmos valued: balance, symmetry, and the delicate seeds of structure. It shows us that from the very beginning, the universe carried an internal order, waiting to blossom into galaxies and stars. It reveals a world shifting from fire into calm, from uniform brightness into gentle variation, variation small enough to hide in noise, yet powerful enough to guide billions of years of evolution. Returning to the first question, we find that the answer lies in the nature of information. Nothing in the universe is ever truly lost. Energy changes form, light stretches, matter rearranges, but the fingerprints of early events linger. Photons released at recombination may have cooled and lengthened, but they still hold the original pattern, tiny ripples frozen into their temperature. The universe remembers because physics itself is a memory keeper. And so this glow is not nostalgia. It is an ongoing presence. It moves through you even now, passing through your body as effortlessly as through galaxies, carrying its memory without burden. You are living inside the universe's recollection of its own birth, wrapped softly in the afterglow of creation. As you rest, imagine this memory unfolding across the sky in a gentle arc. It does not ask for interpretation, it simply offers itself, quiet and patient. We, as observers, are the ones who give it meaning, by listening, by wondering, by tracing its patterns back through time. In doing so, we join the universe in remembering. The first question, why the universe remembers, transforms into a softer truth. The universe remembers because memory is woven into its fabric, because every movement leaves an imprint, because every fluctuation shapes what comes next, and because across billions of years, light has carried the story forward without ever letting go. The CMB is the universe saying, I have been here since the beginning, and I still shine with the memory of what I was. Even though the cosmic microwave background lives far beyond our senses, its presence is constant, quietly wrapping around the Earth, drifting through our atmosphere, touching every corner of night with the gentlest whisper. It is a glow that asks for nothing, demands nothing, and yet it follows us everywhere. As you lie down to rest, this same ancient light passes through your room, your walls, your body, soft, unbroken, unchanged since the universe took its first clear breath. As your breathing deepens, imagine that glow as a dim lantern carried through time. It has crossed distances so vast they stretch imagination, travelling without pause through ages of creation and change. It passed by galaxies forming, stars igniting, planets cooling, civilizations rising and fading. Through all of it, that faint warmth continued forward, not as a message meant for anyone, but simply as a consequence of existing in a universe that once blazed with overwhelming heat. Tonight, it moves through you, not with force, not with sound, but with presence. There is something comforting about this. We often imagine ourselves small within the cosmos, fragile observers drifting on a single world. But the CMB reminds us that we are made of the same universe that produced this light. The matter in our bodies once floated in those early clouds. The atoms that build our thoughts were shaped by the same tiny fluctuations etched into the background radiation. We are not separate from the cosmos. We are part of its unfolding story. The glow that follows you into sleep is not a symbol of loneliness or vast emptiness. It is the opposite. It is connection. It is continuity. It is the reminder that every corner of space, even the quiet one where you rest now, is filled with a memory of creation. A memory gentle enough to soothe, steady enough to endure, quiet enough to calm the mind. As you relax deeper, imagine this glow flowing over you like a warm tide. No direction, no urgency, only steady presence. Imagine it dimming the noise of the day, softening the edges of thought, loosening the tension that gathers behind the eyes and shoulders. This ancient light has seen the universe through every era, fiery birth, restless expansion, and the slow settling into structure. It carries that timeless calm with it. And in a way, letting yourself fall asleep beneath this glow means trusting the universe itself to hold you. Trusting the continuity of light, trusting the memory woven into space, trusting that calm does not need to be loud to be real. The glow that follows us into sleep has travelled across eternity, and tonight it rests with you. At the end of this journey, as your breath slows and your thoughts soften, we return to the quiet glow that began it all. The cosmic microwave background, so faint, so steady, has been with us through every chapter of the universe's history. It is the oldest whisper in existence, drifting through space with patient gentleness. And now, in the stillness of night, that whisper folds itself around you like a calm, endless horizon of light. Imagine the universe as it was when this glow first emerged, a young, brilliant sea of cooling plasma, finally clear enough for light to travel without resistance. In that moment of release, the cosmos exhaled, sending out photons that carried its first imprint, its shape, its temperature, its earliest potential. Those photons have never stopped moving. They have crossed a universe that expanded 1,000-fold, watched galaxies bloom, and witnessed silence deepen between the stars. Yet the message they carry remains unchanged, a memory of the moment the universe first became visible. As you rest, imagine listening to that whisper. It does not speak in words, nor in sounds, nor in anything the senses can catch. It speaks through presence, through continuity, through a soft, uniform glow that says, "I was here, I have always been here, and I am still here now." The universe's oldest light is not dramatic or demanding. It asks only to be acknowledged, to be felt as a calm certainty that connects every corner of space. The CMB reminds us that beginnings do not vanish. They stretch, they soften, they drift, but they remain part of everything that follows. In the same way, every breath you take tonight connects you to the earliest breath of the cosmos. Every quiet moment echoes with the same gentle physics that shaped galaxies from faint ripples. You're not observing the universe from afar. You're inside its memory, its rhythm, its stillness. And so, as the night deepens and your body grows heavier with rest, allow yourself to drift on this ancient whisper. Let the glow that has travelled across eternity wrap you in its calm. Let the continuity of the cosmos remind you that you too are part of something vast, enduring, and profoundly gentle. The universe's oldest whisper is still speaking, and tonight it guides you into sleep. Everything flows. Sleep in that motion,